So here we're given the function k of x is the square root of the sine of 2x. We want to use h equals 0.001 to approximate k prime of pi over 6. So what do I need? We need some information here. I need x and I need k of x. You're interested in what happens with pi over 6. And then I'm going to add 0.001 to that. To determine what those values are. So this is a job for technology, although you could do the pi over 6 part mentally. Sine of 2 times pi over 6 is sine of pi over 3, which is root 3 over 2. So it's the square root of the square root of root 3 over 2. But that's pretty unpleasant. So let's get ourselves an approximation for both of these. And then we're going to recognize that the slope of the tangent is the approximation for the derivative at pi over 6. So let's jump to the graphing calculator and do the analysis appropriately. So our function is the square root of the sine of 2x. So we're going to go to the y equals button, square root of the sine of 2x. We have that. And we're interested in the value of the function at pi over 6 and at pi over 6 plus 0.001. There you go, second vars. This would be regular vars, y vars, function, y1, plug in pi over 6, and what do we get? We get this decimal approximation, 0.9306. And then I want to add a little bit more. I think I said use 0.001. So let's go to vars, y vars, function, y1, pi over 6 plus 0.001. That should give me a number around 0.9306, and indeed it did. So I'm going to plug those numbers back into the table, and then we're going to try to find the slope of those lines, of those points. I have a point here and a point here. I want to find the slope. So the first one for pi over 6, we had 0.93060. And for pi over 6 plus 0.001, I have 0.93114. Remember that k prime of pi over 6 represents a slope. It's a slope of a tangent line. This isn't exactly a tangent line, but it's an approximation. So k prime of pi over 6 is approximately the slope for a small h, and my h here is 0.001. So the slope, change in y over change in x. So k prime of pi over 6 is approximately 0.93114 minus 0.93060 divided by what? Divided by the change in x, pi over 6 plus 0.001 minus pi over 6, which is just 0.001. So if we do that, then what is our approximation for k prime of pi over 6? So doing that subtraction, 0.93114 minus 0.93060, then divide that by 0.001, and the number I get on my calculator is about 0.54. So not a great approximation. It's only 2 decimal places, but at least it gives us an idea of where we are heading with this. Now, what do I want to do next? I'd like to actually determine k prime of x using the chain rule. So we have this function up here. We have k of x is the square root of sine 2x. And I want to determine the k prime of x by using the chain rule. So k prime of x will be the derivative with respect to x. The derivative with respect to x of the square root of the sine of 2x, which is the derivative with respect to x of sine of 2x to the 1/2 power. So let's think about this a little bit. What is the derivative of sine of 2x to the 1/2 power? The derivative with respect to x of sine of 2x to the 1/2 power. We think about our power rule. The derivative with respect to x of x to the n is nx to the n minus 1. So the derivative with respect to x of something to the 1/2 power, pull the 1/2 down in front, 1/2 something to the 1/2 minus 1, we decrease it by 1, of course, times the derivative of the something. Now, what is the something here? The something here is sine of 2x. We're going to get 1/2 sine of 2x to the 1/2 minus 1 times the derivative of the sine of 2x. So we continue and say the derivative with respect to x of sine 2x to the 1/2 power is 1/2 sine 2x to the 1/2 minus 1 to the negative 1/2 times the derivative of the sine of 2x, which you need to think about, because that is going to require another chain rule. This, by the way, means, this first part means square root downstairs. The derivative with respect to x of sine 2x to the 1/2 is 1/2 times 1 over to the negative 1/2 square root of sine of 2x. Now let's talk about the derivative of the sine of 2x. What is that going to be? The derivative of sine of something is cosine of something times the derivative of something. The derivative of sine is cosine, derivative of sine x is cos x, derivative of sine of something is cos of something times the derivative of the something. So the derivative of sine 2x is cos 2x times the derivative of 2x, which gets us where? Here at the derivative with respect to x of sine 2x to the 1/2 power equals, this can become 1 over 2 times the square root of cos 2x times cos 2x. Excuse me, that's an error. Let's quickly fix that. The derivative with respect to x of sine 2x to the 1/2 power is 1/2 times 1 over the square root of sine 2x times cos 2x times the derivative with respect to x of 2x, which of course is just equal to 2. So using this, then what does this simplify to? The 1/2 times 2 just becomes 1. So we have the derivative with respect to x of sine 2x to the 1/2 power equals 1/2 times 2 again, that's 1. Cos 2x is upstairs. And the square root of sine 2x is downstairs. So that's our derivative of the square root of the sine of 2x. Now, what did I want to do? I wanted to find out what is k prime of x. Well, that was k of x. If you remember, k prime of x was the derivative with respect to x of k of x. That's what that notation means. K of x was the derivative with respect to x of sine 2x to the 1/2 power. Or square root. So k prime of x is just cos 2x over the square root of sine 2x. And this whole thing started with us approximating what? It started with us approximating k prime of pi over 6. So what would k prime of pi over 6 be? it would be cosine of 2 times pi over 6 divided by the square root of sine of 2 times pi over 6, which gives me what? 2 times pi over 6 is pi over 3. Cosine of pi over 3 divided by the square root of the sine of pi over 3. And you certainly could grab a calculator now to see what the approximation is, but I'm going to take it one extra step. Cosine of pi over 3 is sine of pi over 6, which is a half, divided by the square root. Sine of pi over 3 is root 3 over 2. So what do I have for k prime of pi over 6? Again, we thought it was about 0.54. So k prime pi over 6 is 1/2 divided by the square root of the square root of 3 over 2. So let's grab the graphing calculator again and see if we get an answer pretty close to 0.54. That will be our goal. So 1/2 divided by, and let's be careful here, the square root of the square root of 3 divided by 2. And I think my syntax is okay. And we hope we get something pretty close to 0.54, do we? 0.537, I feel pretty good about that.